Good afternoon. So in today's class, we shall study about center of a group and normalizer of an element. About these two topics, definitions and theorem of these two topics. So first one is center of a group and second one is normalizer of an element. Okay. Okay. So today let us discuss about center of a group. Okay. Today let us discuss about a center of a group. Center of a group. Okay. Center of a group. So let us consider G be a abelian. Let us consider let G be a abelian. Okay. So which all the elements belongs to G that all elements commute that all elements commute with each other. That all elements commute with each other. So okay, if G if G is the abelian itandra, that all elements no commute one each other agbiಡ್ತಾವ. So if G is not an abelian, let us discuss about if G is non-abelian. G non-abelian itandra, if G is a non-abelian, so then G is a non-abelian ಅಂದ್ರೆ ಏನಂದ್ರೆ ಅದಕ್ಕೆ ಯಾವುದು ಅಂದ್ರೆ ಎಲ್ಲಾ ಗ್ರೂಪ್ ನು abelian ಇರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. Okay, so every group cannot be an abelian. So groups ನು non-abelian ಆಗಿರ್ತವೆ. So non-abelian ಆಗಿದ್ದಾಗ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಒಂದು ಗ್ರೂಪ್ G ಅಲ್ಲಿ ಏನು ಇರಲಿ ಅಂದ್ರೆ ಅಟ್ ಲೀಸ್ಟ್ ಅಲ್ಲಿನ ಐಡೆಂಟಿಟಿ ಇರ್ತದೆ. ಸೊ ಏನಿರ್ತಾರೆ ಐಡೆಂಟಿಟಿ. ಸೊ ದಟ್ ಐಡೆಂಟಿಟಿ ಈಸ್ ಇ. So that identity is E. So E ಏನಾಗಿರ್ತದ ಎಲ್ಲದರ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗಿರ್ತದೆ. ಓಕೆ, E ಏನಾಗಿರ್ತದೆ ಎಲ್ಲದರ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಆಗಿರ್ತದೆ. So therefore G have a same element which commutes with all the elements. So ಏನಾಗಿರ್ತದೆ E ಏನಾಗಿರ್ತದೆ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗ್ತದೆ. Therefore we shall write Ex is equal to Xe for all x belongs to G. For all x belongs to G again. So therefore ಇಲ್ಲಿ ನೋಡಿ G ಒಂದೇ ಎಲಿಮೆಂಟ್ ಇಲ್ಲ. ಸೊ G ಒಂದೇ ಎಲಿಮೆಂಟ್ ಇಲ್ಲ. ಸಿ ಈ ಒಂದೇ ಎಲಿಮೆಂಟ್ ಇಲ್ಲ ಜಿ ಜೊತೆ ಕಮ್ಯೂಟ್ ಆಗೋದು, ಜಿ ಯಲ್ಲಿರುವ ಬಹಳಷ್ಟು ಎಲಿಮೆಂಟ್ ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ. ಸೊ ಆ ಕಮ್ಯೂಟ್ ಆಗಿದ್ದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಅಂತೇವೆ. ಓಕೆನಾ? ಸೊ ಒಂದ್ಸಲ ಏನ್ ನೋಡ್ರಿ, ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಅಂದ್ರೆ ಏನು? ಲೆಟ್ ಜಿ ಬಿ ಎನ್ ಅಬೇಲಿಯನ್. ಸೊ ಅಬೇಲಿಯನ್ ಅಂತ ಏನಂತ ಆಲ್ ದ ಎಲಿಮೆಂಟ್ಸ್. ಸೊ ಆಲ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ಕಮ್ಯೂಟ್ ವಿತ್ ಈಚ್ ಅದರ್. ಸೊ ಇನ್ನೊಂದು ಪಾರ್ಟ್ ಅಲ್ಲಿ ಸೊ ಜಿ ಇಸ್ ಎ ನಾನ್ ಅಬೇಲಿಯನ್ ಅಂತಂದ್ರೆ ಎಲ್ಲಾ ಗ್ರೂಪ್ನು ಅಬೇಲಿಯನ್ ಆಗಲ್ಲ. ಸೊ ಎಲ್ಲಾ ಗ್ರೂಪ್ನು ನಾನ್ ಅಬೇಲಿಯನ್ ಇರಲಿದೆ. So some groups are abelian, some are non-abelian. So in some groups abelian ಇದ್ದಾಗ ಏನಾಗ್ತದೆ, ಅವು ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ ಆಕ್ಚುಲ್ ಆಗಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಇನ್ ಸಮ್ ಗ್ರೂಪ್ಸ್ ನಾನ್-ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ ಏನು ನಾನ್-ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ ಅಲ್ಲಿ ಏನಿರಲಿಲ್ಲ, ಒಂದು ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಇರ್ತದೆ. ದಟ್ ಕಮ್ಯೂಟ್ಸ್ ವಿತ್ ಎವ್ರಿ ಎಲಿಮೆಂಟ್. ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಆಫ್ ನಾನ್-ಅಬೇಲಿಯನ್ ಗ್ರೂಪ್ ಆಫ್ ಜಿ. ಸೊ ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಆಫ್ ನಾನ್-ಅಬೇಲಿಯನ್ ಆಫ್ ಗ್ರೂಪ್ ಜಿ ನಲ್ಲಿ ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ. ಏನಿರಲಿಲ್ಲ ಅಂದ್ರೆ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ. ಓಕೆ? ಸೊ ಈ ಒಂದೇ ಅಲ್ಲ, ಈ ತರ ಬೇರೆ ಬೇರೆ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ. ಬೇರೆ ಬೇರೆ ಟರ್ಮ್ಸ್ ಅಲ್ಲಿ ಜಿ ನಲ್ಲಿ ಇರ್ತಾವ. ಸೊ ಔ ಟರ್ಮ್ಸ್ ಏನಂತೀವಿ ನಾವು ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ? ಸೊ ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಆಯ್ತು. ಸೊ ನೆಕ್ಸ್ಟ್ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್ ಡೆಫಿನೇಷನ್ ಆಫ್ ಎ ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್. ಓಕೆ? Center of a group. Okay? Now next, the definition of center of a group is definition of a center of a group. The set of all those elements, the set of all those elements of G which commutes with every element of G. Therefore it can be written as, so small z, this small z belongs to G, small z belongs to G colon ZA is equal to AZ for all A belongs to G. Okay? So the definition says that the set of all those elements of G which commutes with G. So we write that the statement Z belongs to G, that is ZA is equal to AZ for all A belongs to G. So what I said what I said is, so before I said that before this definition I said that let us consider G be an abelian group. Okay, let G be an abelian group. So ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ G be an abelian group. Abelian group ಇದ್ದಾಗ ಏನಾಗ್ತದ, ಎಲ್ಲಾ ಟರ್ಮ್ಸ್ ನು all the elements ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ನು ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ. ಓಕೆ, ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ನು ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ. ಸೊ ಎಲ್ಲಾ ಗ್ರೂಪ್ ನು ಅಬೇಲಿಯನ್ ಇರ್ಲಿಕ್ಕದ. ಸೊ ಎಲ್ಲಾ ಗ್ರೂಪ್ಸ್ ನು ಅಬೇಲಿಯನ್ ಇರ್ಲಿಕ್ಕದ. ಸೊ ಜಿ ನು ನಾನ್ ಅಬೇಲಿಯನ್ ಇರ್ತದ ಒಂದೊಂದು ಟೈಮಿಗೆ. ಸೊ ನಾನ್ ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ ಏನಾಗ್ತದೆ ರೀ, ನಾನ್ ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ ಕಮ್ಯೂಟ್ ಆಗಲ್ಲ. ಓಕೆ, ನಾನ್ ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ ಕಮ್ಯೂಟ್ ಆಗಲ್ಲ. ಸೊ ನಾನ್ ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ ಕಮ್ಯೂಟ್ ಆಗ್ತಾವೆ. ಯಾವಾಗಂದ್ರ ಅಲ್ಲಿ ಒಂದು ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಇ ಇರ್ತದ. ಸೊ ಇ ಅನ್ನ ಎಲ್ಲದ್ರ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗ್ತದೆ. ಇ ಅನ್ನ ಎ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗ್ತದೆ, ಬಿ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗ್ತದೆ, ಸಿ ಜೊತೆನೂ ಕಮ್ಯೂಟ್ ಆಗ್ತದೆ, ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ ಜೊತೆ ಕಮ್ಯೂಟ್ ಆಗ್ತದೆ. ಸೊ ಈ ಬಿಟ್ಟಿ ಬೇರೆ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ, ಆ ಟರ್ಮ್ಸ್ ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ ಜಿ ನಾಗ. ಮೀನ್ಸ್ ಜಿ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಈ ಒಂದೇ ಅಲ್ಲ, ಈ ಬಿಟ್ಟು ಬೇರೆ ಬೇರೆ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ, ಅವನು ಜಿ ಜೊತೆ ಕಮ್ಯೂಟ್ ಆಗ್ತಾವ. ಸೊ ಆ ಎಲಿಮೆಂಟ್ಸ್ ಏನಂತೀವಿ ನಾವು ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಈ ಒಂದೇ ಕಮ್ಯೂಟ್ ಅಲ್ಲ, ಬೇರೆ 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 ಟರ್ಮ್ಸ್ ಕಮ್ಯೂಟರ್ ಆಗ ನಾವು ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್ ಅಂತ ಹೇಳಿ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ ಅವಾಗ. That is called center of a group. That expression denotes with Z belongs to G colon ZA is equal to AZ for all A belongs to capital G. Okay, this is your definition. Next. Okay. So next we shall go to the theorem. Next theorem. So that is center of a group theorem. So theorem number 35. Theorem number 35. Okay. Theorem number 35. The statement says that the center of group, the center of a group, the center of a group G is a normal subgroup of G. Is a normal subgroup of capital G. Okay, the statement says that what does the statement says? The center of a group G, the center of a group G is a normal subgroup of G. So in the center of a group G is a normal subgroup. So before this proof, so I shall mention, so center of a group G and normal subgroup and define ಮಾಡ್ಬೇಕಂದ್ರ ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಅನ್ನು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಏನು ಇರಬೇಕು ನಮ್ಮಲ್ಲಿ, ಫಸ್ಟ್ ಏನೇನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೇಕು, ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಸೊ ಫಸ್ಟ್ ಇಂದು ನಾನ್ ಎಂಪ್ಟಿ ಸೆಟ್ ಅದೆಲ್ಲ ನೋಡೋಣ ಫಸ್ಟ್. ಒಂದು ಸೆಕೆಂಡ್. ಸೊ ಅದೇನ್ರಿ ಫಸ್ಟ್ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಪ್ರೂಫ್ ಗಿತ್ತಪ್ಪ ಇಲ್ಲ ನಮ್ಮಲ್ಲಿ ಏನೇನು ಟರ್ಮ್ಸ್ ನಾವು ರೆಡಿ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ವಾಟ್ ಆಲ್ ವಿ ಶುಡ್ ಬಿ kept ready for this statement. So first ಅದೇನಾಗಿರ್ಬೇಕ್ರಿ, ನಾನ್ ಎಂಪ್ಟಿ ಸೆಟ್ ಆಗಿರ್ಬೇಕು, second it must be a subgroup, so it must be a subgroup and third it must be a normal subgroup. NSG means normal subgroup. So NSG ಅಂದ್ರೆ ಏನು ಕನ್ಫ್ಯೂಷನ್ ನೋಡ್ರಿ, it is a normal subgroup. Okay, it is a normal subgroup. Okay, so next first we find out it's a non-empty set, non-empty. After that we shall go for a subgroup. After that we shall discuss about the normal subgroup. That is last is normal subgroup. You ಮೂರು ಪಾರ್ಟ್ ಅನ್ನು ನಾವು ಇಲ್ಲಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಿ ತೋರಿಸಬೇಕು. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನಿದೆ ನೋಡ್ರಿ, the center of a group G is normal subgroup of G. Okay, the center of group G ಅನ್ನು normal subgroup G ಅಂತ ಪ್ರೂವ್ ಮಾಡಿರ್ತಾರೆ. ಸೊ ಪ್ರೂವ್ ಮಾಡೋ ಟೈಮ್ ಏನು ಮಾಡಬೇಕು, ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಏನಿರಬೇಕು, ನಾನ್ ಎಂಪ್ಟಿ ಆಗಿರಬೇಕು, ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಸಬ್ ಗ್ರೂಪ್ ಆಗಿರಬೇಕು, ಥರ್ಡ್ ಸ್ಟೆಪ್ ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಆಗಿರಬೇಕು. ಓಕೆ, ಇವು ಮೂರು ಸ್ಟೆಪ್ ಅನ್ನು ಮೆನ್ಷನ್ ಆಗಿರ್ಬೇಕು. ಇವು ಮೂರು ಸ್ಟೆಪ್ ಮಾಡಿದ ನಂತರ ನಿಮ್ದು ಥಿಯರಮ್ ಫುಲ್ ಆಗಿ ಫಿನಿಶ್ ಆಗ್ತದೆ. ಓಕೆ, ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಡಿಸ್ಕಸ್ ವಿತ್. So now let us prove the theorem. Okay, that is proof. Now we shall prove this the theorem. Let z is equal to small z belongs to G, small z belongs to G colon ZA is equal to AZ for all A belongs to G. Okay, for all A belongs to G. This is by the definition of by the definition of central group. CG and this is by the CG and the central group. This is by the definition of CG, by the definition of central group. Okay, in again discuss the definition of central of a group only. So other by using that definition, we write this statement. Okay, since for all A belongs to G. So already said or another A belongs to G and so G alli one identity element yavagnu irthuda. So enu irli andrunu identity element idde irthuda that commutes with E. Now let us see this. Comma EA is equal to AE. Okay, EA is equal to AE. Therefore E belongs to Z. That is Z is a non-empty set. Z is a non-empty set. So we discussed this group. Idu complete aitri. So illi ಏನು ತೋರಿಸಿದೋ non-empty ಅಂತ prove ಮಾಡಿದೆವಾ. Okay, so how we did we prove it? Okay, so let us start with first again. Let Z is equal to Z belongs to G. Therefore, that is ZA is equal to AZ for all A belongs to G. This is by the definition of a central of a group. So since they said that for A belongs to G, that is A belongs to G and or kottidare. Okay, they are given that A belongs to G. That is therefore A belongs to G and A joti one term irla bere yavadana one term idde irbeku. So that will be, we imagine that EA is equal to AE. So E another identity element elladranu irtade. Okay, so identity element elladranu bartade. So for that we wrote that EA is equal to AE, that E belongs to Z now, that E also belongs to Z. Therefore we can write that Z is a non-empty set. Okay, this is the first part of this solution. Okay, your first part has been finished. So exam like first part second part on the bari direct ಆಗಿ ಬರ್ಕೋತಾರೆ ನಿಮಗೆ. So ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗದೆ part 1 part 2 part 3 ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಅದರ ಕಡಕ್ ಮಾಡಿ ಹೇಳ್ತಿದ್ದಾರೆ ನಾನು. Okay, so next, since it can be shown that subgroup of Z is a subgroup of, since it can be shown that Z is a subgroup, since Z is a subgroup of G. So if Z is a non-empty set, then we can say that it can be shown that Z is a subgroup of G. So non-empty set idare enadri absolutely we can say that it is a subgroup of G. So directly subgroup aatadu anta helabodu. Okay, so next next this is the main part of this theorem. This is the main part, next step. So we shown the step 2 here and next step 3 here. Step 3 ತೋರಿಸ್ತಾರೆ ನೋಡ್ರಿ. So we can say that now let us consider G belongs to capital G and small z belongs to capital Z. Okay, so Bn arbitrary. Arbitrary means we are considering, see here. So arbitrary ಅಂದ್ರೆ ಏನಾಗಿರ್ತದ, ನಾವು ಟರ್ಮ್ಸ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿರ್ತೀವಿ ಯಾವಾಗಲೂ. ಆರ್ಬಿಟ್ರರಿ ಅಂದ್ರೆ ಏನು ಅಂತ ಯೋಚನೆ ಮಾಡಬೇಡ್ರಿ, we are considering here arbitrary. So okay, what I said that G belongs to capital G and small z belongs to capital Z. Bn arbitrary. Here we are considering G and Z. Okay. Now consider that GZ G inverse GZ G inverse is equal to G Z G inverse. This is by the definition of normal subgroup. Because we need to find out the normal subgroup there. Okay, we need to find out here a normal subgroup. For that, we are taking by using the definition of normal subgroup, we consider this. Okay, so if ಬೇರೆ ಯಾವ subgroup ಕೊಟ್ಟಿದ್ರೆ ಇದನ್ನೇ ಮುಗಿತಿತ್ತು. So next step what we have to find out is normal subgroup. For that we are considering this by that normal subgroup in definition consider ಮಾಡ್ಕೊಳ್ಳೋದು. So definition consider ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಇದು definition expression ಎಂದರೆ G inverse is equal to GZ G inverse. Okay, so next ನೋಡಿ GZ ಇದ್ದು ನಾ ZG ಬರ್ಕೋತೀನಿ. ZG G inverse. This is by the reversal law. Okay, this is by the reversal law. So again, next we are considering next see what we are doing here. We initiate this bracket to this Z bracket G inverse. So this is the main part. This is the main important points here. So don't be confused anymore. Group start admal properties of groups ಓದಿದ್ರಂದ್ರೆ ಎತ್ತಿ ಎತ್ತದ definition of group and definition properties of group ಓದಿದಂದ್ರೆ ಎತ್ತಿ ಎತ್ತದ. ಇದು ಹೆಂಗ್ ತೊಗೊಂಡಿವಿ ಅಂದ್ರ associative law. This how we consider means by the associative law we change this. So according terms ಅನ್ನ ಈ ಕಡೆ ತಗೊಂಡು. So next ಈ ಪಾಠ ಇಲ್ಲಿ explain ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ. Here I will be explaining the next part of this. Okay, so next what G into G inverse the value ಅಂದ್ರೆ G into G inverse value ಏನಾಗ್ತದ ZE ಆಗುತ್ತೆ. One second, I will forget. Okay, that is it. Okay, now Z is equal to G into G inverse is Z into E ಆಗುತ್ತೆ value. G into G inverse ಅಂದ್ರೆ Z as it is ಬರೀರಿ, E as it is ಬರೀರಿ. E ಅಂದ್ರೆ G inverse E ಆಗುತ್ತೆ value. Okay, E ಬರೀತೀವಿ. So next ಏನಂತ Z into E ಆಗುತ್ತೆ value. So that is ಏನಾಗುತ್ತೆ value ನಮ್ದು Z E ಅಂದ್ರೆ ಏನ್ರಿ E ಅಂದ್ರೆ E means only 1. Okay, E ಅಂದ್ರೆ 1 ಆಗಿರ್ತದೆ. So therefore we can write only a Z. So therefore we can write that Z belongs small z belongs to capital Z. Small z belongs to capital Z. Okay, so next we can write here that G belongs sorry. So GZ G inverse belongs to capital Z for all G belongs to capital G. So hence we can say that H is a normal subgroup. Hence we can say that HZ is a normal subgroup. We can say that Z is a normal subgroup. Okay, normal subgroup. Hence we can say that Z is a normal subgroup. Okay, so what all we did here? So the statement of the theorem is what would the center of a group G is a normal subgroup of a G. So what they are saying? So now on center of a group ada. So the end prove ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು ನಾವು ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಅದ ಪ್ರೂವ್ ಮಾಡ್ತದೆ. ಸೊ ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಇದೆ ಅಂತಂದ್ರೆ 3 ಟೈಪ್ಸ್ ಬೇಕಲ್ಲಿ, 3 ಟರ್ಮ್ಸ್ ಬೇಕು. ಫಸ್ಟ್ ಒಂದು ನಾನ್ ಎಂಪ್ಟಿ ಸೆಟ್, ಫಸ್ಟ್ ನಾನ್ ಎಂಪ್ಟಿ ಸೆಟ್ ಪ್ರೂವ್ ನಾನ್ ಎಂಪ್ಟಿ ಮಾಡಬೇಕು, ಆಮೇಲೆ ಸಬ್ ಗ್ರೂಪ್ ಡಿಫೈನ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ ನಿಮ್ದು ನಾರ್ಮಲ್ ಸಬ್ ಗ್ರೂಪ್ ಡಿಫೈನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಏನಂದ, let z is equal to z belongs to G, that is that za is equal to az for all a belongs to G. This is by the definition of central of a group. Center of a group ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀವಿ ನೋಡಿ, center of a group ಅಂತ ಬರ್ದಿದ್ದೀವಿ. So next, since for all a belongs to G, so in the definition of center of a group they said that a belongs to G. So a ಜೊತೆ ಸಿಂಗಲ್ ಟರ್ಮ್ ಇರಲ್ಲ, ಅದ್ರ ಜೊತೆ ಯಾವ್ದನ ಒಂದು ಟರ್ಮ್ ಇದ್ದೇ ಇರ್ತದ. So we wrote that e ಎಲ್ಲದಕ್ಕ ಕಮ್ಯೂಟ್ ಆಗ್ತದ, ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಎಲ್ಲದಕ್ಕ ಕಮ್ಯೂಟ್ ಆಗ್ತದ. So we wrote that EA is equal to AE. Therefore E belongs to Z, that is Z is a non-empty. So non-empty ಆಗಿರ್ತದೆ Z. Okay, so next, if Z is a non-empty, it can show that Z is also a subgroup of G. So ಏನಾಗ್ತದೆ ಅಲ್ಲಿ Z is a non-empty ಬಂದ್ರೆ ನಾವು ಡೈರೆಕ್ಟ್ಲಿ ಹೇಳ್ಬೋದು Z is a subgroup of G ಅಂತ ಹೇಳಿ. So after that we shall go with the third term. What is NSG? NSG means normal subgroup. Now we shall find out the normal subgroup. Let us consider now. Now let us consider that G belongs to small g belongs to capital G and Z belongs to capital Z. Be an arbitrary. Arbitrary means we are considering here the values of G and Z. We are considering. Next, by considering G Z G inverse is equal to G Z G inverse. This is by the definition of normal subgroup. Why we are taking only these terms? Because we need to find out the normal subgroup. Therefore, we are considering the normal subgroup. Okay. So next we are considering the normal subgroup, and here it is GZ, and next in here this term we are considering ZZ G inverse, because we have taken by the reversal law. We can change this to this here. Okay, we can change this. Okay, we did like this. GZ is now ZG G inverse. Next, by the associative law, we left the Z as it is. We consider only these two terms, G and G inverse we considered. Next, by the G inverse we can write G inverse is equal to E. We have done Z is Z into E. Okay, here Z into C. It is Z into E. Z into E is nothing but 1. Okay, E is nothing but 1. Z into 1 is Z. So small z belongs to capital Z. Therefore, we can write that G inverse G inverse belongs to capital Z for all G belongs to G. Therefore, we can write that Z is a normal subgroup. Okay, Z is a normal subgroup. This is the theorem number 35. That is the center of a group of G is a normal subgroup of G. Okay. So next we shall go with the normalizer of an element. Okay, normalizer of an element. Normalizer of an element. Okay, so next we shall study with the normalizer of an element. Normalizer of an normalizer, ZER, normalizer of element. Normalizer of element. So normalizer of an element. So first we shall study about the definitions of normalizer of an element. Okay, now definitions of normalizer of an element. Okay, the normalizer of an element A belongs to G is the set of is the set of is a set of all those element all those element of G which commutes with A, and it is denoted by N A. Okay, this is denoted by N A. Okay, is denoted by NA, and it can be written as NA is equal to X belongs to G, or bar AX is equal to XA. This is how your definition about normalizer of an element. Okay, so first I will explain this what type it is. Okay, so consider A belongs to G. Let us consider A belongs to G. Consider A belongs to G. A belongs to G. Note hang that commutes. A commute. A nag commutes adala. A nag very different terms irtava. So different very terms irbodu. So commute agiro elements ige ಏನಂತೀವಿ ಅಂತಂದ್ರೆ, one second. This is a small change here. So ಏನಲ್ಲಿರುವ ಸೆಟ್ಗೆ ಕಮ್ಯೂಟ್ ಆಗಿರ್ತಾವೆ. ಆ ಕಮ್ಯೂಟ್ ಆಗಿರೋ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ಏನಂತೀವಿ ನಾರ್ಮಲೈಸರ್ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ ಅಂತೀವಿ. ಇಲ್ಲಿ ತಾನೇ ಏನ್ ಡಿಸೈನ್ ಮಾಡಿದೀವಿ ಸೆಂಟರ್ ಆಫ್ ಎ ಗ್ರೂಪ್. ಸೊ ಏನಲ್ಲಿರುವ ಬೇರೆ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ, ಎಕ್ಸ್ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ, ವೈ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ, ಆರ್ ಎಸ್ ಝೆಡ್ ಟರ್ಮ್ಸ್, ಯಾವ್ದಾರ ಟರ್ಮ್ಸ್ ಇರ್ಬೋದು. ಸೊ ಟರ್ಮ್ಸ್ ಏನಂತೀವಿ ಆ ಟರ್ಮ್ಸ್ ಕಮ್ಯೂಟ್ ಆದ್ರ, ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ಒಂದ್ ಈ ಟರ್ಮ್ ಕಮ್ಯೂಟ್ ಆಯ್ತಂದ್ರ we can say that normalizer of an element. Okay, normalizer of an element. Or so hang up on next, it can be denoted as NA, n of A or n of A ಅಂತ ಬರಿಬಹುದು, or normally we can call it as NA. So NA that is equal to x belongs to G for all AX is equal to XA. Okay, we can say this. So ನೋಡ್ರಿ ಹೆಂಗಂದ್ರೆ ಇವೆಲ್ಲರೂ ಕಮ್ಯೂಟ್ ಆಗಿರ್ತಾರ, ಇದರಿಂದ ಕಮ್ಯೂಟ್ ಆಗಿರೋದ್ರಿಂದ ದಿಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ನಾರ್ಮಲೈಸರ್ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಈ ಎಲಿಮೆಂಟ್ಸ್ ಏನಂತೀವಿ ನಾರ್ಮಲೈಸರ್ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಿ ಕ್ಯಾನ್ ಡಿನೋಟ್ ದಿಸ್ ಬೈ NA is equal to x belongs to G. x G ಅಲ್ಲಿರುವ ಟರ್ಮ್ಸ್ ಇದು ನೋಡ್ರಿ, G ಅಲ್ಲಿರುವ ಟರ್ಮ್ಸ್ ಇದು. ಓಕೆ, ಡೋಂಟ್ ಫಾರ್ಗೆಟ್ ದಟ್ G ಅಲ್ಲಿರುವ ಟರ್ಮ್ಸ್ NA is equal to x belongs to G, AX is equal to XA. Okay, this in the term of the x is a term of G. Okay, so now let us discuss about the definition of an normalizer of an element. So the normalizer of an element A belongs to G. A belongs to G ಅಂತ ಹೇಳಿದ್ರೆ A belongs to G. A ಅಲ್ಲಿರುವ elements A belongs to G is a set of all those elements. So ಇದರಲ್ಲಿರುವ ಎಲ್ಲಾ set of elements of G. These also belongs to ಒಳಗಿರುವ elements ಎಲ್ಲಾನು ಏನಿರ್ತಾರೆ belongs to G ಆಗಿರ್ತದೆ. So the set of all those elements of G which commutes with A, so ಎಲ್ಲಾ elements commutes with A ಆಗ್ತವೆ. It commutes with A ಆಗಿರ್ತದೆ. That is called normalizer of an element. So next ಇನ್ನೊಂದ್ಸಲ ಆಯ್ತು ನೋಡ್ರಿ, the normalizer of an element ಅಂದ್ರೆ the normalizer of an element A belongs to G. A belongs to G is the set of all those elements. ಇದರಲ್ಲಿ A ಇರುವ ಎಲ್ಲ elements, the set of all those elements of G which commutes with A. So ಇದರಲ್ಲಿರುವ ಎಲ್ಲ elements ಇದರಲ್ಲಿರುವ ಎಲ್ಲ elements ಕಮ್ಯೂಟ್ ಆದ್ಮೇಲೆ ಆ ಕಮ್ಯೂಟ್ ಆಗಿದ್ದಕ್ಕೆ ಟರ್ಮ್ಸ್ ಏನಂತೀವಿ ನಾರ್ಮಲೈಸರ್ ಆಫ್ ಅನ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. That is, it is denoted by NA and its expression is NA equal to X belongs to G, AX is equal to XA. This is your definition of normalizer of an element. Okay, this is no normalizer of an element. So next we shall discuss the theorem number 36. ಇದರ ಮೇಲೆ ಯಾವುದು ಓಕೆ ಇದೇ ಟರ್ಮ್ ಮೇಲೆ ಅದನ್ನು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಅದ ನೋಡಿ. Next, that is theorem number 36. Theorem number 36. Okay, that is theorem number 36. The center of a group. The center of a group is a normal. The center of a group is a normal subgroup. The normal subgroup is a normal subgroup of a normalizer of an element. Okay, normalizer of an element. Okay, normalizer of an element. Next, proof. Now, what does the statement in note first? The center of a group is a normal subgroup of a normalizer of an element. Normalizer of an element. So next, for A belongs to G. The normalizer of A is NA is equal to X belongs to G, that is AX is equal to XA. Then by the center of G, the center of a group. So next by the center of next now by the center of group. By the center of group ಏನು ಡಿಸೈನ್ ಆಗ್ತದ? So by the center of group G is Z is equal to small z belongs to capital G, or AZ is equal to ZA for all A belongs to G. Is that A belongs to G? So next, what is that? To show that the center Z of group G is a normal subgroup. Is a normal NSDN normal subgroup of NA. NSD means normal subgroup of NA. Understand so here lengthy word there. Now we have what we have. Let us see. We have for all small z belongs to capital Z. Therefore, we can write this Zx is equal to xz for all x belongs to G, capital G. Therefore, we can write also Az is equal to Za is equal to Az as A belongs to G. A belongs to G. Therefore, Z belongs to small z belongs to capital G. Sorry, small z belongs to NA. Okay, small z belongs to NA. NA. Therefore, we can say that if A belongs to NA, Z is a subset of NA. Z is a subset of NA. Since Z is a subset of NA, since Z is normal, Z is normal in G. Z is normal of NA. Normal in NA. Okay, normal in NA. So here is your theorem number 36. So let us discuss about the theorem number 36. The center of a group G is a normal subgroup of a normalizer of an element. The statement in the center of a subgroup is a normal subgroup. That should be a normalizer of an element. Normalizer of an element NA. Normalizer of an element in NA. Okay. So next, what all we have for to solve this? So we are having for A belongs to G. When A belongs to G, the normalizer of an element. Normalizer is by the definition of normalizer of an element we are considered here. I will be writing here by the definition of normalizer of an element. NA, normalizer of an element. Sorry, NAE, normalizer of an element. Okay. By the definition of by the normalizer of an element, we took that NA is equal to X belongs to G bar AX is equal to XA. Okay, we have did this. Now next, by the definition of normalizer consider next time by the definition of central group of G. So center of a group G Z is equal to Z belongs to G, AZ is equal to ZA for all A belongs to G. So we know that A belongs to G, Z belongs to A. So Z belongs to A and A belongs to Z. Now to show that center Z is a Z of group G. Z of group G is a normal subgroup and prove. So we have Z belongs to Z, small z belongs to capital Z. So Z one day terms N elements add. So we have written that here NA X ZX is equal to XZ because one element abelian group we can term this as an ZX is equal to XZ because of for all X belongs to capital G. As usually A jote Z jote n commute agitte inondu Z jote inondu n commute agidire AZ. So AZ is equal to ZA is equal to AZ for all A belongs to G. So ಎರಡು terms G ಎರಡು terms X ಮತ್ತು A G ಜೊತೆ commute ಆಗ್ತಿತ್ತು ಅದಕ್ಕೆ ನಾವು ZX is equal to XZ ZA is equal to AZ ಅಂತ ಬರ್ಕೊಂಡೆವು. So therefore we can write Z belongs to NA. Z belongs to normalizer of an element. So ಯಾವಾಗಲೂ Z belongs to NA ಐತಂದ್ರ it directly proportional to Z is a subset of A. So ಯಾಕಂದ್ರ Z ಯಾವಾಗಲೂ belongs to NA ಐತಂದ್ರ ಅದು directly proportional to the Z is a subset of NA. Since Z is a subset of NA ಐತಂದ್ರ ನಮಗೆ ಏನು ಹೇಳ್ತಾರೆ we can say that Z is a subset of NA ಐತಂದ್ರ since Z is a normal subgroup in G. ಯಾವಾಗಲೂ Z is a subset of NA ಬಂತಂದ್ರ Z is a subset of anything ಬಂತಂದ್ರ that Z or anything number contained is a normal subgroup in G. Therefore it is a normal subgroup in G andra since Z is a normalizer in an element. Z is a normalizer in element and directly we can say that by the definitions of center of a group. Okay, thank you. So ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಇಲ್ಲಿಗೆ ಮುಗಿತಾ. We will continue tomorrow.